Hello. This presentation is a part of our semester-long project in DevOps. We will be presenting the continuous delivery pipeline, as developed over 4 milestones. We started by setting up a basic configuration management system using Jenkins Server. Then after focusing on the testing and analysis of the two applications, we improved the deployment strategies and infrastructure of the app. Finally, we built monitoring services for the infrastructure and the application. We started with provisioning and configuring Jenkins Server automatically using Ansible. With the help of Jenkins Job Builder and Ansible, we create and build jobs for the two applications: a Node.js web application, Checkbox.io, and a software enterprise Java system, iTrust. On successful build, we provisioned and configured separate Amazon EC2 instances for each of the application, as a part of the post-build. Moving on to the test and analysis part. We added JaCoco plugin to provide code coverage reports for each build right inside the Jenkins. We then developed a tool that automatically commits new random changes to source code, which will trigger a build and run the test suites against the fuzzer branch. It then rolls back the changes after the job was submitted. We examined 100 commit results of fuzzer runs and generated a prioritization report for each job build, sorted by execution time and the number of tests failed. This report helps in prioritization of useful and necessary tests. We then created a program that automatically generates the test cases. After mocking the database handle and using test data, we find the different possible routes of the API requests by creating an abstract syntax tree with the help of a schema parser. On your left is an example of the code that handles the incoming API requests. We then extract the possible parameters in the requests and their expected values, and generate the tests as shown on the right. To implement continuous delivery, we have registered Git webhook on both the application's GitHub repositories that sends HTTP post request to Jenkins when there is a commit pushed by the developers. This in turn triggers the Jenkins jobs, which will first run the test cases by pulling the new code on Jenkins server itself, and if all the test cases pass, it will create the EC2 instance for deployment of the respective application or use an already existing one. To create scalable and fail-safe infrastructure, we deployed Checkbox.io on Kubernetes cluster. The application uses MongoDB and Nginx, so we created separate pods for each of the components and exposed them by creating a service. Finally, the application was accessed through a node port service on Nginx pod. We then created a Redis master-slave architecture, consisting of feature flags for different functionalities, replicated over to the slaves. The application checks if the feature flag is switched on, before showing a particular feature. As you can see, the flag is initially set to true, which is why we were able to create the survey. After switching off the flag, we try again to create the survey, but we are not allowed to. We implemented the ability to perform a canary release by using a proxy/load balancer server, route a 25% of traffic to a newly staged version of software and remaining traffic to a stable version of software. Now if there's an alert raised on new version, it will stop routing traffic to canary. In the real world, we can't let our applications down even for a fraction of a second. We achieved this by using the rolling updates. We had 5 replicas on 5 different instances. Using the DNS, we updated our application by updating 1 replica at a time, while the user will still be able to access the other versions. To provide good visibility into our containerized infrastructure and its orchestration, we have enabled the Kubernetes dashboard. Using Heapster backed up by InfraDB and Grafana chart services, we can monitor our pods, services and even nodes. In our special milestone, we are monitoring the Kubernetes cluster setup in the previous milestone. On the screen you can see the dashboard showing the status, CPU usage, memory used, of the pods and the deployments for Nginx, MongoDB, and Checkbox separately. Going a level higher, we can also see the health of the different nodes inside the cluster, so that we are aware when one of the nodes go down. To monitor Jenkins job builds, we have integrated Jenkins Slack bot into our Slack team. This will help various teams to communicate easily while job builds are in progress, successfully completed, and failed. Teams no more have to keep looking at Jenkins web interface, while log Jenkins jobs are taking long time. This was our implementation of the entire pipeline. Thank you for watching.